In this video, I'd like to talk about simplifying roots of negative numbers. And with these example problems, we're going to be given the square root of some negative number, and we need to express this radical using the imaginary unit. And remember that I is defined as the square root of -1. So we will rewrite this square root as some multiple of I. And when you have a square root of, let's say, some product, A times B, you can rewrite this as the square root of A multiplied by the square root of B. So in other words, if you have the square root of a product, you can rewrite it as a product of two square roots. And we can use this idea to simplify our square root here. So for starters, if we take the square root of -49, we can rewrite this as the square root of -1 multiplied by 49. And since we now have a product here, we can rewrite this as a product of two square roots. So we have the square root of -1 multiplied by the square root of 49. And we know the square root of -1, we've defined that as I. That's the imaginary unit. So we're just going to replace that with I. And now we have I multiplied by the square root of 49. And 49 is a perfect square. Since remember that 49 is really just 7 squared. And when you have a square root of something squared, or when you have a square root of a perfect square, this will simplify to a whole number. Since the square root and the square will cancel each other out, and you just get 7. Since remember, this is really just asking what number multiplied by itself gives you the thing underneath the square root sign. Or in this case, what number multiplied by itself gives you 49. And we know that's just 7. So we can rewrite this as I multiplied by 7. And usually we're going to write it with the real number first and then the imaginary unit. So in our box here, the square root of -49 is really just plus or minus 7 times I. And this particular problem was not overly difficult because, like I mentioned, the square root of 49, that is the square root of a perfect square, and so we get a whole number. But in cases where it's not a whole number, it's a little bit more challenging, though you will follow the same strategy. So let me just make a little bit of room here. And let's look at a different example. Let's say we have the square root of -40. Now, in the beginning, we'll follow the same strategy. We're going to separate this into a product of -1 multiplied by 40 so that we can create a product of two square roots. So square root of -1 times by the square root of 40. And the square root of -1 we know is just I, so we get I root 40. And 40 is not a perfect square. So when that's the case, what we want to do is essentially make a tree so that we can find all the prime factors of 40. So when making a tree, just ask yourself, what two numbers multiply together to give you 40? And they could be any combination that you can imagine. So it could be 2 and 20, it could be 4 and 10, it could be 8 and 5. It's whatever you want that actually multiplies together to give us 40. So let's do 4 and 10. And 4 is a perfect square. That's 2 times 2. And 10 is 2 times 5. So when simplifying the square root of 40, we can separate it into its prime factors. And it's usually a good idea to pair them up if you can. So we can pair these 2's together. So that's 2 squared. And then we have 2 and 5. These are unpaired. And the reason we do this is now we can separate this into a product of square roots, where we have the square root of 2 squared. So any perfect square underneath this square root can go in its own square root. And anything that's unpaired, or anything raised to the first power, that can go into one square root together. So we can just put 2 times 5 together, since we're not going to find a whole number square root of either of these factors here. So the square root of 2 squared, which is just the square root of 4, we know that's 2. And the square root of 2 times 5, we're going to just rewrite that as the square root of 10 since we can't simplify this any further. So our final answer here for this I times the square root of 40, or in other words, the square root of minus 40, is just I multiplied by 2 root 10. And like we did with this example problem, it's a good idea to put the number terms first. So you get 2 root 10 multiplied by I. And I do want to make note that you need to be careful here so that you're not writing the I underneath the square root. So a lot of times you can put a little mark there just to denote that the square root has ended. So when writing these by hand, just make sure to note that the I is not inside the square root.